Hello guys, today I'm going to be solving some iGCSE Circle Theorem questions for GCSE, iGCSE as well. These are questions based on Edexcel board. So I'll try to explain these questions as best as I can under a few minutes, right? So there are total 3 questions here that I would be like to solve. Also that solving these questions would help you guys to understand how to approach circle theorem questions that appear on your exam paper. Okay, so let's begin. Alright, so A, B, C, and D are points on a circle. TDV is the tangent to the circle at D. So that is this tangent here. Alright, tangent here. Okay, work out AB is equal to AD, angle ADT is equal to 71 degrees. Work out the size of angle BCD. Give a reason for each stage of your working. So there are a total of 5 marks, and the diagram is not accurately drawn, so that means you don't need to measure it or anything. So what are the keywords that are given here? So we know that angle ADT is equal to 71 degrees. So now in order to find the size of the angle BCD, you have to use something called the alternate segment theorem. The alternate segment theorem means that the value that is for ADT is going to be equal to the value that is of ABC. So anything that is touching like the tangent is equal to making the chord. So you see a chord, AD is a chord, it'll be equal to the angle on the opposite side of the segment. Okay, so the segment here is going to be equal to 71 degrees. So angle ADT is going to be equal to angle ABD, that's equal to 71 degrees. Give a reason. The reason is because of alternate segment theorem. So the alternate segment theorem. So this is alternate segment theorem is something that you need to remember, that the angle that is formed near the tangent and the chord is equal to the angle on the opposite side of the chord itself. Alright? So then now based on this we have to find out angle BCD. Angle BCD is the angle that is here that we need to find. We have to find this angle here. Now in order to find that, what can you look at when you're looking at the shape? You know that all points, both A, B, C, and D, they all touch the circumference of the circle. This implies that this is a cyclic quadrilateral. So since this applies that it's a cyclic quadrilateral, we know once we find out what BAD is, angle BAD, angle bad, once we find out what angle bad is, we can easily use the cyclic quadrilateral rules, as where the opposite angles in a cyclic quadrilateral, they all add up to 180 degrees. Now, another comparison you can make out quickly is that you can see there are 2 strokes of lines that are being indicated here. So this implies that this is also an isosceles triangle, So the triangle that is shown here, both A, B, and D, we have to find out this angle BAD, angle bad, and we're given that angle ABD is equal to 71 degrees. So we can indirectly find out what angle BDA is. So, or we could just rephrase that and say angle ADB is going to be equal to angle ABD is equal to angle 71 degrees. This is because, the reason is because the base angles, because there are 2 strokes of lines that indicate it's an isosceles triangle. Base angles of an isosceles triangle is equal, you can mention that as well, are equal. So this is also 71 degrees. Now all you need to do in order to find angle bad, you just do 180 degrees minus 71 degrees plus 71 degrees, and you find that out by subtracting both angles added, because the angles in a triangle, they all add up to 180 degrees. Angle BAD, you can just mention that step there as well, that the angles in a triangle, they add up to 180 degrees. So angle bad is 38 degrees. Now what we can do is angle bad plus the angle that we want to find, BCD, is equal to 180 degrees. The reason is because the angles in a, let's just reload this again, let's see if it works. Yeah, the angles let's just write that clearly, because that statement is most important, that the angles in a cyclic quadrilateral are equal. The angles in a cyclic quadrilateral are equal. So angle BCD is equal to 180 minus 38 degrees, because these two angles are equal. They're indirectly related to each other. They both add up to 180 degrees. 180 minus 38 degrees should give you 142 degrees as your answer. And you can just write there in space there 142 degrees. So 142 degrees is your answer. Alright, so then you can score those nice 5 marks by stating some good reasoning and examples. Alright, so let's move on to the next question. This diagram is also not accurately drawn, so that means we don't need to measure it or something. So B, C, D, and F are points on the circle. A, B, C, E, F, D, B, F, E, and C, D, E are straight lines. Work out the size of angle X. Sure, you're working clearly. So now, in order to understand this, you have to observe it that indirectly they're saying that B, C, F, and D, they are cyclic quadrilateral. They're indirectly implying that it's a cyclic quadrilateral. So it's pretty easy to find out X just by finding out what this angle D. So we have to find out what angle CDF is, so that they're correlated with each other. So now, in order to find what CDF is, we have to do what we call is something called X plus angle CDF. CDF is equal to 180 degrees. That's because the angles in a cyclic opposite angles. Remember, sorry guys, did I mention opposite angles there? Oh yeah, we have to mention the word opposite angles in a cyclic quadrilateral. Okay, so just remember to put that point there as well. Opposite angles in a cyclic quadrilateral. They add up to 180 degrees. So we know we can indirectly find what CDF is equal to 180 minus X. So this angle here is 180 minus X. Now, what else you need to know? You need to know that in order to find what, we have to look at this triangle, because they have given you a value of 54. So that means we have to involve this triangle as well, C, A, and D. So we're given 54 degrees. We're given what 180 minus X degrees. We have to find out what angle ACD is. That is this angle here. Right? We have to find out what this angle here represents. So what you can do, we're just going to say angle ACD is equal to C. So we can do, by analyzing that question, we have to find out what angle ACD is, right? So by observing this question is a bit tricky, but we have to carefully examine what we have to do clearly in order to find. We have found that CDF is 180 minus X when we know that angle ACD is equal to C, right? Angle ACD is equal to C. So what we can do is 54 degrees plus Z plus Y plus Z plus C. I'm trying to find out like how to solve this question, because it looks a bit tricky at start, but if you understand the concept well, you can get it. So we're going to do that something like X plus Z plus 32 is equal to 180, because we're trying to find out that, oh yeah, we can remember we have mentioned that CDF, we can also mention that here, that CDF, that angle CDF is equal to Y. So what we can do is angle CDF, instead of calling it 180 minus X, we can just call this Y as well. So we know that 54 degrees plus Y, that is CDF. So that is somewhere, because F is a point there, so CDF is Y plus 32 degrees is equal to plus, so not 32 degrees, sorry guys, plus Z is equal to 180 degrees. Now your next portion should be understanding how this question works. We have to use this triangle as well and find a correlation for that triangle. So this triangle shows us that it is C. We have to correlate with this triangle here. We have been given 32 degrees as well. So CBE should be given as well. So we're given 32 degrees. We know what X is. We have to find out what BCE is. So we can call angle BCE as Z as well. So we have Z plus X plus 32. They all add up to 180 degrees. Clearly, we can use this equation to find out what Z is, right? Based on that, we're going to simplify this equation. 54 degrees plus Y plus 2 is plus Z, not 2, sorry guys, plus this is Z is equal to 180 degrees. And we're going to rearrange the equation for the value of X, since we know that Z of X plus Z plus 32 is kind of equivalent to each other. So in order to find out what Y is, we have to replace Y with X, and we're going to get the equation of X minus 2 is equal to 54 degrees in the question. Alright, now X plus Z, X minus Z, this is because we're doing 54 plus 180 minus X plus Z. Now this is important that we understand that the reason is we're looking at this portion of the question, right? With the value of Z plus X, we're just inputting it there and getting the value of X minus 2 is equal to 54. This is basic algebra substitution that you need to remember. And now you have X plus Z plus 32 degrees is equal to 180 degrees. I'm just rearranging this equation here. And then you have X plus 2 is equal to 148. So we have made this equation, and we have two equations, and we can solve them through the elimination method. This is a tricky question, but you have to just understand the concept. So once you do this through the elimination method, all you need to do through the elimination method is get 2x is equal to 202 just by adding them, because minus 2 plus 2 is equal to 0. And you find out what X is equal to. X is equal to 202 divided by 2. X should be equal to 101 degrees. This is your answer, just by relating it to 32 degrees as well as 54 degrees. Alright, let's move on to the next question. That question was a bit complex, but once you grasp the idea of the relationships through elimination method, you can understand the question. A, B, C, D are points on a circle center O. AOC is the diameter of the circle. Angle AOD is equal to 98 degrees. Work out the size of the angle DBC. Give a reason for each stage of your working. So what is the angle DBC? That is this angle here. So first question, depending on the last question, we have to look at the values that were given to us, and based on that you form triangles, right? We form larger triangles, we form smaller triangles. So we're given the value of 98 degrees. So what does this imply? This implies that angle ABC, we can easily find out what angle ABC is, right? So now in order to find what angle ABC is, we know that we can remember that the angles in a semicircle, there's another rule of the circle, is that where angles in a semicircle is equal to 90 degrees. So we know that angle ABC indirectly at this huge angle here ABC is equal to 90 degrees. Now the reason is because the angle in a semicircle is 90 degrees. That's 90 degrees. Now we can find out what ABD is, right? So we know that angle ABD, not ABC, ABD is equal to angle AOD, that is given to us as 98, divided by 2. The reason is because, I'm going to state it now, is because the angle at the circumference, the angle at the center of a circle is twice the angle at the circumference. What does this imply? Is that the angle at the center circle is 98. It is twice the angle at the circumference, so it's twice ABD. So that's why we are dividing AOD by 2, because it is twice. So ABD, to find ABD, is 49 degrees. So we know that angle ABD, that is this portion here, is 49 degrees. Now to find out what, since the whole triangle, the whole angle of ABC is 90 degrees, in order to find out what your angle DBC is, you just need to do angle DBC is equal to angle, the whole angle is ABC minus angle ABD. That is 49 degrees. So ABC is 90 degrees, the whole angle, minus the small angle that we have found through using the rule angle at the circumference of the circle is twice the angle at the circumference. So 90 degrees minus 49 is technically going to give us 41 degrees, and that is your angle for finding angle DBC. So angle DBC is going to be equal, angle DBC is going to be equal to 41 degrees. So DBC, that is this portion here, is 41 degrees. There you go, you solve the question. 41 degrees is your answer, and you score those good 4 marks, alright, by stating the reasoning as well, because the question states give a reason for each stage if you're working. So I think that's it for solving some complex circle theorem questions. If you guys enjoyed the video, please do like, share, and subscribe. It'll help the channel a lot. And please do comment below if you want me to keep on solving past paper questions or solve questions on certain topics. It'll really help as well. Otherwise, just enjoy the video, and we'll see you on the